All right. So now that you have finished viewing that video and have hopefully had an opportunity to respond to the video, hopefully you felt confident in your response and that it wasn't overwhelming or defeating. As long as you watched the video, you should have been good. So, what I want to do now is kind of take some time to break down that video and explain what they were talking about. It did go kind of fast, and they did discuss maybe some higher order words, some concepts that may have been unfamiliar to you. So I would like to go through and kind of break it down. So the first thing I want to address is that term antibiotic. And we did discuss it a little bit earlier, but I want to define it and give you a little bit more information. So, an antibiotic is a medicine that prevents the growth of or destroys bacteria. And now, some people are thinking, or have maybe I've had students ask me in the past, how does this work with the flu? If I get how come if I get a flu shot, how come I can still get sick? Um, and the same could be said about COVID. There have been, news stories of people who got it once and then got it again. And it's got all of these, varying instances with COVID and with other illnesses. And what I need to draw your attention to is that there are certain illnesses that are from bacteria, and there are certain illnesses that are from a virus. Okay. COVID, the flu, those are viruses. Okay. Bacterial infections are something that they use to treat antibiotics. If you have the flu, if you have COVID, strep throat is bacterial. Sometimes it can be viral, depending. But if you have an illness and it is a viral infection, okay, you cannot take antibiotics. It will not help you because antibiotics are created to destroy bacteria. If it's not bacteria, it's not going to be impacted. Now, there are certain instances where you could potentially see this happening with viruses, but that would be something called antimicrobials, which is something totally different. Same concept, they're just using different terms. So it is separate. I don't want you to um, think that this is the same thing as COVID, as the flu, all of that. Those are viruses. We're focusing on bacteria. The same process could occur. There has been, discussion in the news about different strains of COVID, but that is not because of antibiotic resistance or even antimicrobial resistance. That is because the virus is essentially adapting its genetic traits, its genetic material is changing, and it's becoming an entirely different virus. Okay. So that's what they're talking about when you hear different strains. That's what happens when you get the flu shot and then you still get sick. Okay. It's because the flu shot you got is not for the new strain. So, and we can get into this a little bit more later if this is a conversation that you're interested in and you'd like to talk about it some more. I'm more than happy to discuss this with you. But I know that some of you guys are like asking these questions as I'm going through this. So, even though we're not in class live together, I was hoping to be able to answer some of those questions for you. Okay, so the next important thing that you understand about antibiotics is that they are used as a medicine to treat and cure diseases caused by bacteria. So, again, If it is an illness, if it is a disease caused by a bacteria, antibiotics could be effective with it. If it is a virus, antibiotics will not work. Okay. And then just an interesting little fact here is that the first antibiotic discovered was penicillin, and it was actually discovered by accident, which is very interesting. And if you want more information on that, you can look it up, or we can discuss it at a later time. But yeah, it was actually occurred and was discovered by accident. So I'm hoping that now you have a little bit more of an understanding of bacteria as a whole. And we're going to go ahead and move to our next slide. So looking at resistance, whoops. Sorry, I hit the wrong button. Looking at resistance here and antibiotic resistance, we're going to address it in a couple of ways. You will see as we go through this, I have our main points of natural selection here so we can make that connection. Because really being able to understand those points, we have to be able to make that connection and actually see that process occurring. Okay, so our main points of natural selection, we've got two. So we have four. The first two we're going to focus on are individuals of the same species have different traits. So looking at this example here, this image, and you're going to be looking at it shortly, but looking at this image here, each of these dots represents a different bacterium. Okay, same species. Okay, you could call this, bacteria J. It could be whatever you want it to be. It's just an example. Okay, and each colored dot represents genetic variation. So if we were thinking about or connecting this to the peppered moths that we looked at on Monday and Tuesday, whether or not the peppered moths were light colored or dark colored, how speckled they were, those are all variations in traits. Okay, thinking back to last week with the brown bear and the white bear, that's a variation, same species, different traits. Okay, so looking at this population of bacteria that all have different traits, okay, each color, if we look at this scale here, each color represents a different level of resistance. So if it is yellow, it has low resistance. If it is red, and the darker red it goes, the higher resistance it is. So on the next slide in your Nearpod, okay, I would like for you to answer a question based on this diagram. I want you to tell me what you think the population will look like when when an antibiotic is introduced or exposed, when this population is exposed to an antibiotic. Okay, so on the next slide, tell me in your own words, what is your prediction? What do you think will happen?